All right, let's do it. Okay. Okay. I'm back. Today we're going to be looking at these two engines. So we're going to be looking at this Honda engine, 1.6 L4 VTEC. BMW engine, 3-liter L6. It's got the VANOS on it. So which is VANOS, I believe, is the BMW acronym for its variable valve timing. So I'll show you some of that stuff on this, and I'll show you the VTEC stuff on the Honda also. Okay. All right, let's do this. Let me go turn my speaker down in my other computer because I'm getting a little bit of feedback. Okay, what do we have here? All right, we've got this Honda engine. We'll bring it down a bit. All right, so there's the cylinder head from, it's actually a Honda Civic. This came from a Honda Civic SIR. So a very special engine. These engines only came back in the late 90s, early 2000s on the SIR. So this was a 1.6 liter VTEC engine. There was no other VTEC engine that was 1.6 liters in displacement. So pretty neat. So off cover. Yeah. There you go. Double overhead DOHC VTEC VTEC. There you go. No gas. There was no gasket on that because gaskets in the container down here on the bottom. All right. Double overhead cam. Camshaft one. Camshaft. Let's take them out. Okay, all right, so camshafts are out over here. All right, what do we have? We got our cylinders in here, all right, and we've got lifters, rockers right here. Now, what's neat about these rockers is they're adjustable. And what I'm going to be able to show you is how you make an adjustment on these particular rockers here. So the only way that you can see the adjustment on this is if I get the camera closer. So what I'm going to do is instead of bringing the camera closer, I'll try and bring the cylinder head closer to the camera. So let me just bring this over. Okay, so if you guys can see this, here's a rocker. Here's a rocker right here. Maybe you can see this one better. No, you can't. So there's a rocker right there. And on this rocker, okay, this rocker, so this is almost very similar to a roller rocker, but there isn't a roller on here. This is just a surface that the camshaft lobe rides on, okay? But my pivot point is on the far end. So my rocker is going up and down, but my pivot point is on the far end. So I can't really show you this that well because I can't get that. Sometimes this camera cuts out if I do this, but let's just try it anyhow. Okay, so there is my rocker, okay? And as you can see, my rocker is pivoted on this side here. So let's look at this one or this one. So you can see it here. So here's my rocker here, okay? And my rocker pivots on the inside. So it's kind of like that roller rocker that we saw in the video today, in this tutorial, okay? And then what's neat about this one, and you're not gonna see it on any of the other engines, okay? It was only this one. Now, why was it kept adjustable? Because these little SIRs, they were meant to like basically like pick them up from the dealership and go throw them on the track or just have some fun with them. They were meant to be a small little pocket rocket, right? But Honda hadn't moved to hydraulic lifters as yet, all right? Or hydraulic lash adjusters, because they still had these, all right? So they hadn't moved to hydraulic lifters as yet. So they had these, which needed to be adjusted. So the way that this works is there's a little screw. So there's a little screw right here, and there's a little locking nut right here. And you could undo this locking nut. And what you could do is you could take this screw and you could turn the screw in or out. So luckily, I've got a screwdriver here. So I'm going to take this screw, turn this screw out. So what I'm going to do is I'm going to show you. Undo this nut, and I'm going to screw this in. All right. So when I screw this in, let me just show you how this works. So I'm going to screw it in, okay, and take a look. If you guys can see this, I can't see it. Okay, so if you guys can see what I did here, take a look at what I did. All right, so I've just adjusted this. Sorry, this canvas. There we go. All right. So what I did was I turned this screw, and look how long the screw is at the bottom here, right? So I can adjust the screw to make it, I can make it longer from here to here, or I can make it shorter by turning the head of the screw here. And all you have to do is unlock this little nut that's here. So on this Honda engine here, it's got manually adjustable valves. All right. So this is probably the only engine that does not have, this is the only engine that we have here in the class that doesn't have hydraulic valve lash adjusters. Now, what do we have on this engine that's different? Again, we saw the tutorial today. Valve spring. Ooh, check this out. Oh, another valve spring, all right? So this engine had dual valve springs, okay? So inner spring, outer spring, okay? They're not variable rate because the windings are all the same throughout, okay? Same with this, all right? The windings are the same all the way throughout, so they're not variable rate, but we're using two springs. And why are we using two springs, guys? Because two springs can apply more force, okay, than one spring in this case, all right? And you can clearly see that this one is far bigger than this one, okay? Coil diameter, all right? Coil diameter and physical size of the spring as far as the windings, okay? So this one's a little smaller on looking at it this way, all right? So this Honda had dual valve springs. Valves, they've got 3 valves out. Now, I didn't ask them to take 3 valves out, no big deal. They took an extra one out. I'm fine with that, okay? Intake, exhaust. Why? Because on this engine, we've got an even number of valves per cylinder, okay? And you can see the difference. Now, take a look at this, guys. This is the exhaust valve. And the exhaust valve is coated, okay, in what's called carbon, okay? So that carbon comes from burnt oil. So this engine had faulty valve stem oil seals. And the oil was running down from the top, running down the stem of the valve, and then eventually accumulating on the top of the valve. And when we started the engine, okay, the oil would leak in and it would burn. The problem with that also is because the valve is running so hot, the oil that's not burned away efficiently in the combustion chamber, it hardens. And when it hardens, it turns into carbon. And that carbon can really cause a big issue. All right. What that will do is it will prevent the valve from seating. So that means the valve won't be able to close because all this carbon is kind of jammed in between the face of the valve and the seat of the valve. And that causes a big problem. If you look at this one, here's the intake valve. Look how much cleaner it is, right? Because the only thing coming out of that, guys, is air and fuel. And because there was no oil leaking past the valve stem oil seals, okay, it's nice and clean. It almost looks brand new when you're looking at it. Like it's just beautiful, right? Obviously, you had oil burning inside the combustion chamber. So now on this side of the intake valve, okay, we've got carbon. So there you can see traces of carbon. That's basically burnt, hardened oil. So when you're burning oil within your cylinder, you get this carbon, these carbon deposits, because that's what happens when you basically cook oil, right? So if you take the oil, you get it incredibly hot, it turns into carbon, all right? So exhaust, intake. Let's do what I'm going to show all. I'm going to ask all of you guys to do this. I'm going to ask you to take your valve assembly, and I'm going to ask you to show me how this whole thing works. So you've got your valve, you got your springs, okay, and then on top of that, you've got your retainer. So now your retainer goes like that. And again, I'm going to try and show it to you as close as possible. Oh, and what do we have here, guys? We've got our two keepers or locks. So we've got the two keepers or locks. And what I'm going to do is I'm going to put all of this together, and I'm going to show the teacher how this all goes together. So I'm going to take my locks, I'm going to put them in my groove. So you've got your little groove right here on the valve stem, okay? Put them in here. Put this one here. And once you put it in correctly, remember what I told you guys? Once you put it in correctly, that keeper or the lock is kind of conical shape. I don't know if you guys can really see that, but it's conical shape. And that's going to allow me to put it into my retainer. And once I do that, okay, look how it fits. Fits like a glove, nice and tight. Okay, nothing sticking out. All right. And we've got them all locked together. So that's how it works. As long as you've got tension from your spring pushing up on the retainer, all right, this assembly is going to stay connected. If the spring was to fail, so if the spring was to fail and it was to break or it was to lose its tension, okay, what would happen is the retainer would come down. And you see what's going on with my locks? All it would take was one opening and closing of the valves. On my locks, I'm going to put my hand there so they don't fall on the ground. My locks would pop out. And when the locks pop out, okay, when the locks pop out, the valve would drop down into the combustion chamber, and that's where it would get destroyed by the piston, okay? There we go. Now let's take a look at what's going on the opposite side of this engine. Woo-hoo! Okay, so in here, and this sucker's pretty heavy. So we've still got the intake on this engine. Same with the BMW engine. The BMW engine still has the, no, it doesn't, has nothing connected to it. So let's take a look at the cylinder head. All right, and where are the valves missing? The valves are missing up at the top. So cylinder head, rockers. Now what's neat about this, guys, is this thing has got VTEC. And let me kind of show you how it works. So if you're looking closely, I've got two valves per cylinder. Now, I've got two valves per cylinder, but I've got one. Let me go up here. This is 1, 2, 3. So I've got one rocker here for one valve, another rocker here for the other valve, and in the middle, I've got another rocker, and that rocker basically rides on a third cam lobe that's on the camshaft. So here's how the VTEC works. Here's my camshaft for this engine. Can you see it? See, yeah, you can probably see it on this one. All right, so here's my camshaft. When we're looking at this camshaft, take a look. Can you guys see that this camshaft here, it's a little bit higher, so it's taller than this one. So if I'm looking at that one, okay, it goes up to about, well, where my finger is pointing to. This one is a little bit higher. So this cam lobe is a little bit higher than this one. What does that do? If you've got a higher cam lobe than this one, this will allow the valve to open deeper into the combustion chamber. If we allow the valve to open deeper, we can either let in more air or we can let more air out. So lower camshaft lobe, lower camshaft lobe. This lobe and this lobe, they're the same, okay? So they're identical, but this one is a little bit higher. And then if you look at it this way, boy, nah, you really can't. Can you see it? Yeah, you can see it a little bit here. Now, again, because I'm a one-man show here, guys, it's very hard for me to do this, but take a look. This is the front cam lobe here. And then if you're looking at it, look at the one behind it. You see the difference in the height? Okay. Not only is there a difference in the height, the lobe itself is also a little bit fatter across here. So if we're looking at it this way, the lobe is fatter across here than this one. What does that do? It allows the valve to open sooner and close later. So think about it this way, guys. If you've got a valve that opens sooner and then it closes later, that means it's open for a longer period of time. If we keep the valve open for a longer period of time, we're going to be allowing more air into the cylinder or more air out of the cylinder. All right. By pushing the valve deeper into the combustion chamber, we can squeeze more air in or we can push more air out. Here's how the VTEC system works. The VTEC system at regular RPM, so anything below, say, 3,000 RPM. I think it starts actuating about 2,500 RPM. Okay, so anything below 2,500 RPM, or maybe let's call it 3,000. I can't quite remember what it is. It's either 2,500 or 3,000, but I think it's 2,500. So when you're running around town and you're not, really racing the engine, okay, you've got this and this, these two rockers working on the smaller cam lobes on your camshaft. Keep this up here, okay? So we've got this rocker and this rocker working on the smaller cam lobes, this one and this one, okay? The middle one is working on this one, which is a bigger cam lobe. So it's allowing the valve to go deeper into the combustion chamber, and it's also allowing the valve to stay open longer. So here's what they do. What they do is they've got these little mechanisms inside here, and there's like a little, I can't really press it out. There's a little plunger in here. And what happens is, depending on the RPM of the engine, depending on where it's set, when the VTEC comes in, what the VTEC does is through oil or hydraulic pressure, what the VTEC system allows is it allows this rocker here to lock onto these two rockers. So now we've got this rocker and this rocker locked to this one. And because this one's following a bigger lobe on the camshaft, both of these valves now, they open earlier, they close later, and they go deeper into the combustion chamber. That's going to allow more on this side here, in particular, this is the exhaust side, that's going to allow more air out of the engine, okay? On the intake side now, so this is the intake manifold, so this got to be the intake side, okay, because it's leading to this right here. So same thing, we've got a rocker here, right? We've got a rocker here, we've got a rocker here, and one here. So there's three rockers, okay? And both of these outside ones, this one and this one, these are the ones that touch the valves. This one never touches the valves. But when the VTEC kicks in, there's a little plunger in here. There's kind of like, I don't really know how to describe it. It's kind of like a tube. And what that tube does, okay, is when the oil pressure is sent to it, okay, that little tube pushes out. And when it pushes out, it locks the other rocker together. So the little rockers have a little hole like this. And when that tube pushes out from the middle one, it goes into the second one and it locks the valves together because you've got a little tube coming through here. All right. So that's how the VTEC works on this one. All right. And so that's why when you're looking at the camshaft has got, let me just move this out of the way. The camshaft has got 3 lobes. 1, 2, 3. These, normal operation below 2,500 RPM. This one, VTEC operation above 2,500 RPM or maybe 3,000. I can't quite remember what the RPM range is. And why do we want to do that, guys? The faster the engine is revving, the more fuel we can pull in, and the more exhaust gases we can push out, the better the performance. Okay. So with a race engine would only have a big lobe like this all the time. But the problem with that is the engine won't be able to idle, not below 1,000 RPM. If you've ever gone to the car races and you listen to these cars, they never idle at below 1,000 RPM. They're idling at like 2,000, 2,500, maybe even 3,000 RPM so they can continue to run because my cam profile is so aggressive. So with VTEC, we've got the best of both worlds, all right? We can run the engine around town, right? At low RPM, it'll idle beautifully, it'll give us great fuel economy, all right? But when we want to kill it, when we want to go a little bit faster, all right, when we want to rev this engine up, the engine is going to be able to breathe better. So all of a sudden now our lungs have gotten bigger, all right? And by allowing the cylinder head to breathe better, we're producing more power in the engine. So VTEC is for Honda. VANOS is what they use for BMW. VTEC is Toyota, okay? For Nissan, it is VVTI stands for variable valve intelligently timed. VTEC is variable timing electronically controlled. VANOS is variable. Don't ask me, but that's their acronym for BMW. Nissan uses. I don't know why I'm drawing a blank here. I think Nissan is just VVET rather than VVTI, which is variable valve timing electronically controlled, right? Honda uses VTEC, valve timing electronically controlled, and Toyota uses VVTI for variable valve timing intelligence. Basically, it's controlled by a computer. So every manufacturer is using this type of setup where at low RPM, okay, one cam low profile, at a higher RPM, a second cam low profile, we open the valves earlier, we close them later, we push it deeper into the combustion chamber, and we make that engine breathe heavier or better at a higher RPM. Let's flip this sucker around. Now, we're looking at this engine, all right? And what are the questions I'm going to ask you? I'm going to say, okay, guys, what's this thing right here? And if you guys look at this, you're going to go, oh, sir, that's the exhaust port. And how do we know it's the exhaust port? Because you know what? If I take a little screwdriver and I do this and I run it from this port, oh, it magically appears at the exhaust valve. So this must be the exhaust port because what is a port? A port is simply just a passage that it's just a passage where air can either come into the combustion chamber or come out of the combustion chamber. And because this is an exhaust port, okay, it's a little passage that allows air to come out of the combustion chamber. These intake valves here, because they're bigger, they're going to lead to my intake port, which is on this side, and obviously it runs up into my intake runner, right? So my air is coming into here, and then my fuel will be injected somewhere directly right here on top of my intake manifold. It mixes with the air, and then when the valve opens, the air enters the combustion chamber. What else do we have here? Oh, take a look at this. Now I know you guys can see this. Cylinder 1, 2, 3, and 4. All right. Well, this is the front of the engine, and this is definitely cylinder 1, 2, this is 3, and this is 4 because it's at the back of the cylinder head. Okay. We've got a spark plug. Oh, the spark plug is centrally located. I wonder what type of combustion chamber we have in this Honda engine. Of the 3 types, there's only one type that has a centrally located spark plug, and we all know what that is. So again, we've got a manufacturer by the name of Chrysler or Dodge, if you want to call it, or Ram. They're all the same. they're all under Chrysler Incorporated, okay? They're allowed to say that their engines have a Hemi, the only truck with a Hemi. That's what you hear in the ads. And what did I tell you guys before? I told you guys that many manufacturers use a hemispherical combustion chamber, but Chrysler is the only one allowed to advertise that. Why? Because they patented the name, so now they've got the rights to calling their engines Hemis, all right? So the only truck with a Hemi. Really? No, everybody else is using a Hemi. They just can't say that they're using it, okay? So 4 valves per cylinder. If you've got 4 valves per cylinder, the exhaust valve is going to be a little bit smaller, and the intake valve is going to be a little bit bigger, okay? What else are we looking at here, guys? Remember what I told you? I'm going to ask you guys to show me the passageways for your engine. So let me just bring this down a bit. There's 4, all right? I'm going to say, where are your coolant jackets? And where are your oil galleries? And what you've got to do is you've got to be able to look at it and recognize where they are. So here's what I'm going to tell you. There's 2, 4, 6, 8, 10. There's 10 holes here, and there's 10 holes here for your cylinder head bolts. Cylinder head bolts are quite long. They go through our cylinder head and bolt the cylinder head to the block. Okay, so when we're looking at all this, guys, we got 2, 4, 6, 8, 10 holes, and those are for the cylinder head bolts. The rest, what we've got to look at to find the water passages are going to be around my combustion chamber. So they're going to like encapsulate my combustion chamber or surround my combustion chamber. And that's where the coolant is going to be. Why? Because this area here is getting really, really hot. And we want to remove that heat through the coolant flowing through our cooling system. So cooling system passages, water jackets, okay? Water jackets surrounding the cylinders. Now, we have to be able to look at this cylinder head, and we've got to be able to tell where the oil passages are. So let's just take a look at the oil passages. Oil has to be able to flow from the cylinder head back down to the block. Now we've got these massively big holes. Okay? Here's what I'm going to do. I'm going to shove a head bolt through it. Taking a head bolt from the top, I'm going to shove it through. So you can kind of see it trying to come out here. Okay, I'll take this. I think this one might be a little bit easier. I'm going to take this. Okay, and you guys can see it coming through. So that rod is coming through. So this hole here, this one, and probably this one, those are all drains for the oil that's in the cylinder head to flow down back into the oil pan. Okay, that oil is in a cyclical system where the oil, gravity feeds it back down to the bottom of the oil pan, and the pump sucks it up and pushes it back up to the cylinder head. Now, on this cylinder head, you've got to look and you've got to figure out where the heck does the oil from the oil pump, how the heck does it get up to all of the moving parts? So now when we're looking at it, I'm looking at it. Water jackets, cylinder head bolt holes, oil galleries going back down to the block, okay? This right here, and it's sealed with the head gasket. This is where the oil pressure from the oil pump goes up into the cylinder head. So this one single hole here, that is the only hole that allows oil under pressure to go up to the cylinder head and feed everything on the top of the cylinder head that's moving. So we've got the camshaft that's spinning. We've got all the rockers that are going up and down. We've got, we don't have any lifters in here as such because it's all manual. It's all manually adjusted, okay? Everything that's on the top of the cylinder head that needs to be lubricated must be lubricated. So the only hole or passageway that leads from the pump up to the head is this one right here. So that one goes up. The rest of them, these big ones here, they allow the oil to flow back down, including this one here. So that allows the oil to flow back down into my oil pan, okay? I don't think I'm gonna ask you guys any other questions about something like this. So the only other question I can ask is what kind of material is your cylinder head made out of, and you can justify what the material is based on a couple of different things, right? And you guys all know the couple of different things is aluminum alloy is lighter. Aluminum alloy doesn't need to be painted because it doesn't rust. So it's usually shiner in composition and there's no paint on it, right? So this cylinder head is done. I've shown you everything in this cylinder head. I showed you the valves. The only thing that we didn't speak about was the parts of the valves, but you guys are probably well versed in that. Every day I kind of go over it. I can go over it again today when we're finished over here on the BMW head, but let me just set that up, okay? So let me flip this back around again. I didn't show you the guides. I didn't show you the, let's see if you can see it. I don't think you can see it. Let me see if I can bring this close. Okay, so if I do this, I do this. Can you guys even see the guides? I don't think you can. Yes, you can. So there you go. So I flipped this around and you guys can see my valve guides, okay? And my valve guides, my valve guides are, I'm getting the pointer. You guys can see it here. You can see my valve guides here. And you can see the, ooh, hang on, where are you looking? Where are we looking? There we go. All right, so you can see the valve guides here. And you can see the valve guide up here, right? So you can see this guide right here. See this guide right here? And you can see this guide right. Oh, it's these two you're seeing. Sorry, guys. You can see this guide right here. Okay. Then down below it, you can see this guide right here. So those are our valve guides. Okay. And they're usually a different color. Okay. Flip it around. What didn't I show you guys in this head? And I'm going to try and do it. Let's see if you can even see it. Let me get a light. Let's see if you can see it. Let me get a light. I'm just going to get a light and I'm going to show you. So take a look in this head. Let's see if you can see it. Can you see it? Yeah, now with the light you can see it, okay? So now that I'm shining the light on it, you can see it, okay? And what are we looking at? What's in here that I want you guys to be able to see? I want you guys to be able to see this way. I can turn it this way. Okay, I want you guys to be able to see this thing right here. So what am I looking at right here? I'm looking at the valve stem oil seal. So that's the valve stem oil seal. And then immediately below that is the valve spring seat. Okay, so we've got the valve spring seat. That's where the valve spring sits on. And we've got the valve stem oil seal. Okay, rockers right here. Rocker, rocker, rocker. These two touch the valves. Okay, and that's why you've got your adjusting screws on there to take up the adjustment. So you've got this one touching the valve, this one touching the valve, and they've got an adjusting screw on it. Then you've got this thing, and that is only responsible for the VTEC, to ride on the VTEC cam lobe, okay? And then in the back here, I forgot to tell you guys, all right? I forgot to show you this, all right? So you've got the valve seat right here, okay? And when you're looking at it, guys, it doesn't even look like it doesn't belong in there, right? So that valve seat is replaceable. This valve seat here is replaceable, okay? So if you guys, when you guys are looking at these things, you really can't see it when you're looking at it this way. But when I'm shining the light in here, I could see where it ends. So I can see this seat and I can see where it's pressed in, okay? There we go. VTEC engine, all done. It's down, guys. Wait. Wait. I'm gonna put my camshafts back in and I'm gonna put my cover back on. A couple of rockers that are giving me. Look at that pin. That pin's come out. That's why these things wouldn't go back down. Okay, so I've got this pin. Push it back down. There we go. Okay. I can't show you guys the pin, but yeah, the pins are sticking out, and that's why this wasn't going down. So, cam number one. I know you really can't see it that well. Let's see if I can pick it up. Okay, cam number one is in. It's not in. We don't have the bearings in. Okay. I'm gonna leave all of the valve stuff right here on the bench, okay, because no one's coming in. I'm gonna pop a cover back on it. And the only reason I'm gonna put the cover back on it is just to kind of dust and stuff, all right? Over here, and again, these guys have done a good job. I'm gonna say these guys, but it was Khalil, okay? Because Khalil is one of the only guys in this group that's doing this work. So I'm gonna put your valves and your springs, I'm gonna put everything back in here, okay? Just to make sure that they don't get lost. And what I'm gonna do is I'm gonna putting the valves together like that, okay? And I'm gonna tuck in the keepers underneath, and that way they don't get lost, okay? So we've got valves, keepers are in here, valve, spring, keepers are in here. One, okay, so maybe the keepers are okay, so I've got the keepers in here. Two valves, I've got the third valve coming over here, and I'm just gonna leave it here, right by your engine. When you guys come back on the 24th, all your stuff is here, and it's all safe, okay? Let's move on to the BMW head. Okay. I'm gonna move this out. Let's see. BMW. Okay, so BMW cylinder head, okay? Neat. Okay, so the BMW cylinder head is pretty neat because it's got variable valve time, but they do it in a different way, all right? So what BMW does is they use a separate shaft. So this shaft right here, okay, is a little shaft and it's on a little gear here. So it can turn. So my finger has this little gear here, and there's a little motor that sits on top of this here. And that motor has a little gear that meshes with this. And you can see me turning this, all right? And what they do is, depending on the RPM of the engine, a signal is sent to the motor, and this thing is allowed to move like this. And when it's moving, what ends up happening is it increases duration and it increases lift on the valve simply by these little, on this little shaft here, they've got these little eccentric lobes, okay? And those lobes kind of act like a separate camshaft, okay? And it moves depending on the RPM of the engine. So they've got variable valve timing in this, they just do it slightly different. They use different mechanisms. Now, what's neat about this, and I think one of the things I told you I was going to tell you is, this one, you can really see the hydraulic lash adjuster, okay? So now you guys should recognize this. Ooh, does that look similar to what we were looking at today in the tutorial? So we were looking at valve operation today, and they were showing you this thing. And they were showing you this thing, and they called it a hydraulic lash adjuster. Now let me just do this. I'm going to spin it. When I spin it, oh my goodness, is there also a hole in it? Yes, there is. There's a little hole right there. And that little hole, exactly like we saw in the tutorial today, that little hole is where the oil gets forced into this hydraulic lash adjuster. Now watch what I can do. If I take it in my hand and I squeeze it, okay, you see how I can squeeze it. The reason I can squeeze it is because there's no oil in there. So once we pump oil into it, I can squeeze it, okay? Sorry, once we pump oil into it, I wouldn't be able to squeeze it. So this slack that's here now, because there's no oil in it, when we pump the oil into it, the oil would push this plunger up. This plunger gets pushed up and it becomes solid. So the oil acts kind of like, well, it uses its properties, which is ideally you're not supposed to be able to compress or squeeze a liquid, okay? So a liquid is really not compressible. And once you pump in oil into there, okay, you fill it up tight with lots of oil pressure, this thing won't be able to do this. When it's cold, it can do it, all right? We pressurize it, so once we start the engine, we pressurize it, okay? This becomes firm and stays up in that position. And what do? We get rid of all the clearance. So as soon as the engine starts, pressure comes in, all right? And there is a tiny bit of give. Even when there's lots of pressure, there will be a little tiny bit of movement, okay? And that'll allow for expansion and contraction of the parts. So there's my hydraulic lash adjuster, okay? We just call it a lifter, hydraulic lifter. Take a look at what happens now. In my engine, we've got my rockers. Oh my goodness gracious. Does that look like what we saw in the diagrams too? Let me show you why they call it a roller rocker, okay? It's a roller rocker because there's a roller. Like I showed you guys in the 3.6 GM. The GMs have roller rockers with the same setup. The only difference is there's no little clip. So on the bottom of this roller rocker, there's a little clip. And that little clip allows us to put that lash adjuster into it, okay? And so now my rocker is rocking on the adjuster, which is on the opposite side of the valve. In our tutorial, guys, all of the hydraulic lash adjusters were on this side where it contacts the valve. On this engine here, on the GM, on the Audi, they all use the hydraulic lash adjuster on the opposite side of the rocker, okay? And then on the rocker here, we've got a little roller. That's a little roller. I'm rolling my fingers on it, okay? If you guys are up close, I could show it to you, but I'm showing it to you here. So that's why they call it a roller rocker, because it's a rocker with a roller on it. There's bearings in here, and I can roll that, okay? So hydraulic lash adjuster, the little rocker, and that little rocker is going like this, up and down with the cam lobe, and it's riding on the cam right here. So the cam is pushing this little rocker up and down, and this little hydraulic lash adjuster is taking up the space between the tip of the rocker and the valve, okay, where it's on the top of it, okay? And as the engine warms up, okay, this moves up a little bit higher to remove any kind of clearance between the rocker, tip of the rocker, and the valve. Now, how do I show you how this works? Let's see if I can show you. Let's see if I can bring this closer. This one's going to be a little bit difficult because I don't think I can't lift it up because it's big and bulky and heavy. So let's see what I can do here. Okay. All right, so here's how this works. My little lifter, that little lifter goes into a little hole right here. So you see these little holes here, okay? Those are for all my hydraulic lash adjusters. So they just kind of go in like this, okay? So all my hydraulic lash adjusters, they just kind of fit in this hole like, let's see which one's better, this one? Yep. Okay, so that goes in there, all right? So my little hydraulic lash adjuster fits into these holes, all right? And you can see these holes. There, I've just put them in, all right? Now, this end of the hydraulic lash adjuster, right here, circular end, fits on my rocker. They kind of clip together, so neat, okay? You put this in here like this, okay? And that goes in, and then if you guys can see, here's my valve right here because there's my valve spring and there's my valve. So this goes in like this. And my lifter, sorry, my rocker sits across here. So it pivots on this hydraulic lash adjuster right here. So it doesn't actually move, it rocks just like this, but the difference is it's actually pressing down. So if I pull it out here and I put it in here, maybe you guys can see it. Can you guys see it? It's not very good. Let's see if I can. Let's see if I can. This. so if I do this, let's see if you guys can see it. Can you guys see my rocker? Yeah, there's my rocker there. All right. And what's my rocker doing? When it's riding on the camshaft, it's going up and down like this. All right. And when it's going up and down like this, it's pressing on my valve. All right. So it's pressing on my valve and it's forcing that spring to compress and opening my valve. So where does my camshaft go? So let me just show you. Inside this assembly here, inside this assembly is my camshaft. So this goes here like this. Let me just open it up and show you. So inside this assembly, we've got a camshaft. So there's my camshaft. And the camshaft is long because it's a 6-cylinder inline engine. So there's my camshaft right there. Okay. There's the camshaft for this engine. It's quite long. I don't know if you guys can see all of it, but there it is there. And you can clearly see my camshaft lobes. So if you're looking at this camshaft, you can see the lobes, right? There's the lobes on the camshaft. And as the camshaft rotates, the valve can open and close because you've got the lobes, right, that are eccentric, okay? So once we put this in here, my cam, as it's rotating, rotates on my rocker, which is right here, and that in turn causes my rocker to go up and down, okay? So as my camshaft sits right here, okay, as my camshaft sits in here, as my camshaft is rotating, you can see the lobes on it, right? And as the lobes are rotating, it's pressing down on those rockers, okay? Right now, there's no rockers in here, so there's no resistance. If I was to put a rocker in, it would stop and you would see it kind of jam up, okay? So there's my camshaft, it rotates, it's gonna hit my roller rocker. There's my roller rocker. And if we just kind of do this upside down, my roller rocker rides on the camshaft like this. And as the camshaft spins, causes my rocker to go up and down, okay? Roller rocker, hydraulic lash adjuster, pretty neat. Now, I know you guys that are in this group, I know you guys that were in this group didn't really take a lot of time to study this stuff, but when you come back on the 24th, you'll be able to see it, okay? So I'm looking at the time, guys. I'm gonna respect your time. I don't want you guys to be spending too much time here. So I can give you time to do your quiz if you haven't had it done. So let's pull this out. Okay, so now we've got the rest of this that I've got to show you. Again, these guys did a good job, okay? And what they did was they put their valves over in the corner. Oops, you can't see it. Okay, so what they did was they put their valves over in the corner here. I'm not sure if, no, I think I did. They had their valves in here. So they had their valves in here along with their locks or their keepers and the springs. So what do we have? Take a look. An intake valve and an exhaust valve. And can you guys see the difference in color? All right. So you can see the difference in color. Why? Because when the intake valve is open, what's coming through the passage? Air and fuel. That's going to wash or keep this valve clean. What's over here, guys? What's coming out on the exhaust side is burnt, hot exhaust gases. All right. And that's going to discolor this area here. All right, on the valve. And so that's why when you're looking at it, it's all dark like that because you've got hot, burnt, hydrocarbon-filled gases coming out of the exhaust side, and you've got clean, fresh air along with some fuel that washes our valve. So when you look at the intake valve, it's physically bigger than the exhaust valve, okay? But it's nice and clean on the backside of the head. Whereas on this one, it's just black. Okay, from the hydrocarbons coming out of the exhaust system on this car. All right, so valves. Intake valve, okay? Intake valve, and if you're looking at the intake valve and you're looking at the face, it's a heck of a lot smaller than the face of this. So when we're looking at it, guys, I'm not sure if you can see it, but the face here on this is much smaller than the face here on this one, okay? This exhaust valve here, the face goes from here to the top here, all right? It's quite big, all right? This one here is maybe 1.5 millimeters. This one here is about 2.5 millimeters, okay? So the face on the exhaust valve is always bigger. And look what they have, okay? All right, they've got a tapered spring or a trapezoidal spring. Again, we saw that today in valve operation, all right? And that spring goes over the valve, spring, retainer. Let's push up my retainer so you guys can see it. Okay, valve, spring, retainer, over the spring. And if you're looking at this valve, guys, look, it's got not one, not two, but 3 grooves, all right? So it's got 3 grooves here, and that matches our keepers. So our keepers also have 3 matching protrusions. Again, 6, when I ask you to put this together, you're gonna put it together the way you're supposed to put it together, okay? My little keepers are on there. And then what do? I push up my spring. There we go, look, fits like a glove, okay? So we've got valve, keepers in there, retainer here, and the spring. And as long as the spring is pushing up, this all stays good. If the spring gets damaged in any way, it loses its spring tension, it breaks, it cracks, okay? And it manages to come down like that, all right? The retainer will come out, the locks will come out, and then all hell breaks loose, because what happens is the valve has nowhere, it's not secured anymore to the retainer, it's got nowhere to go but go down, and it drops into the combustion chamber or the cylinder, okay? Now, I'm doing the Volkswagen last, and the reason I'm doing the Volkswagen last is because the Volkswagen is pretty special. We'll do the Volkswagen on Friday, but there's a couple of things on the Volkswagen engine when you look at it you'll never seen on any of the other engines, because it didn't happen to the other engines. On that Volkswagen engine, the timing belt broke. And when the timing belt broke, the valves got hit by the pistons. And when the pistons hit the valves, it bent the valves. Then, with continued battering against the head of the valve failed. And then the valve broke. And then we had the head of a valve, which is just this part of the valve, okay? At this part of the valve, just kind of literally bouncing around inside the combustion chamber and the cylinder. And what it did was quite catastrophic, okay? So the head of this valve broke off, okay? So just the head broke off, was bouncing around inside the combustion chamber and cylinder. So it damaged cylinder walls, it damaged the piston, obviously the valve got damaged, and the combustion chamber got damaged. So that car needed an engine when that was done. And why did that happen? The customer just neglected to replace his timing belt. When the timing belt isn't replaced, guys, over an extended period of time, it can fail. And when it does fail, guys, it can cause catastrophic damage within your engine, especially if you've got an interference engine. Now, let me pull this out. I'm gonna pull out my rocker. I'm gonna pull out my hydraulic lash adjuster right here. I'm gonna put it in here. I'm putting my valves, just like you guys did. I'm gonna put the valves back together. So valve, spring, retainer. I'm gonna put it just like this. I'm gonna put my 2 little keepers. Just put them in the box, okay? Valve, spring, retainer, and I'm gonna put them all in here, okay? The intake valve and the exhaust valve are physically different. So I've got to do this. So my exhaust valve is physically bigger than the intake valve, the stem of it. So only one retainer will actually fit. Because the stem is physically bigger for the exhaust valve, it won't fit through the intake valve. So let me show you. So you guys look at my retainers, okay? So because my intake valve is smaller, my intake valve fits this one because it's smaller. But my exhaust valve, the stem on the exhaust valve is physically bigger. It won't fit in this one, okay? It doesn't fit, okay? It won't go through. It won't go through, it's too big, okay? So we've got to put it in this one which has a bigger hole, slightly bigger, okay, so that it can go through. All right, so on this particular engine, the exhaust valve is physically bigger. You guys have got everything here. Don't have to worry about it. Let's take a look at what's going on in your cylinder head. I can't lift this cylinder head. I don't want to. I'm going to hurt myself, okay? Not because it's too heavy for me, but I mean, it's not going to be stable, all right? So I'm going to try and bring my camera to the head rather than bring the head to the camera. So let me get my pointer. Woo, pointer. And we've got, oh my God, we got 5 minutes. Let me just show you quickly. I'm going to bring my camera. Woohoo! So my camera is looking directly inside the cylinder head. Okay, what are we looking at here, guys? Here's what we're looking at. All right, we're looking at right here. Okay, if you guys can see it, right there, I've got my valve spring seat right there. And you can see that it's a different color, okay, than the rest of the cylinder head because it's made out of steel. And right here, I've got my valve stem oil seal, okay? That all goes underneath my spring, all right? So valve stem oil seal right here, valve spring seat right here, okay? Next, let's take a look on the opposite side of the cylinder head and let's see what we can see, okay? So let me flip this over. Oh my gosh, and this is absolutely beautiful. Okay, so if we're looking at this cylinder head, let's see if you can see it there with just my camera. Oh man, all right, BMW cylinder head. This thing ran out of oil, but this thing was running so great. Like the passages are still so beautiful, it's unbelievable. And it's absolutely nothing like the Kia that we looked at, not the Kia, the Hyundai, all right? If you guys remember, I showed you guys someone that polished, took 8 hours just to polish this area here for 4 cylinders, all right? With a little polishing tool. Take a look at this, guys, all right? This is how BMW does things, okay? So we were looking at a Hyundai engine. Now take a look at what BMW does. Can you look at that port, okay? When we're looking at that port, it's as smooth as can be, all right? Now, could we make it a little bit bigger and maybe a little bit smoother? Possibly, but there is absolutely no comparison between a BMW head, okay, and a Hyundai head, all right? That port is as smooth as can be from the factory, all right? And that would be part of my intake port because that's coming out of the intake valve. And where's it going to, guys? It's going into this area right here. So let me get my pointer again. Here's my intake port right here. Let's see where it comes out. Okay, so there you go. All right, so there's my intake port. I apologize, I can't catch all of it, but I'm pushing it through. Okay, and I'm pushing it through, and you can see, look, my intake port here where my hand is, right over here, there's my hand, and it's coming through on the intake valve side. Okay, where's my exhaust port? Again, my exhaust port is going to be on this side, and you can see it coming out here. And when you look at the difference in color between the intake port and the exhaust port, you'll see the difference. Okay, can't really show you. Let me see if I can do it. Oh, okay, maybe. I just don't want this to drop on me. All right, so if you guys are looking, take a look at my intake port. Nice and clean. And again, this intake port looks like what that guy port is polished on the Hyundai, and this is straight from the factory. Nice and clean, nice and smooth, and you can see my 2 intake valves there on the edge of my intake port, okay? And then if you look at the exhaust side, what I told you, what color is it gonna be? It's gonna be black. All right, so if I can show you this, let's see if I can show you this. Here's my exhaust port, and my exhaust ports are all black because you've got all those hydrocarbons coming out of the exhaust port, okay? Good. Now, that's it for my cylinder head. It is now 1:30 exactly. Oh, I forgot to show you, and I want to show it to you because I've got 3 people in this group that might be wondering, okay, where are all my water jackets? Where are all my oil galleries? So let's take a look, guys. Remember what I told you? My water jackets, they're going to surround the cylinder. So water jackets, water jackets, water jackets, water jackets. There, this is all water surrounding my combustion chamber. So anything that encirculates or encapsulates the combustion chamber are my water jackets. Okay. What do we have here? Oh, what we have here is an oil gallery that allows the oil from the top of the cylinder head to flow down into the oil pump, into the oil pan. 1, 2, 3, 4. These are just passageways that allow the oil to flow back down into the oil pan. All right. Over here, same thing. 1, 2, 3, 4. Those are just passages that allow the oil to flow back down into the oil pan. Now, just like the Honda head, all right, there's only one area where the oil that's forced up from the oil pump goes into the head, and it's right here. Let me just take a look right here. Okay, so oil that's forced up and it goes into this hole right here, and this hole has a hole that's up at the top. There's also a hole here, all right, that's going to force the oil through galleries so that it lubricates all the moving parts on the opposite side of this head. So not on this side, but on the other side of the head, all right? That little area here is where the oil pressure, okay, or oil under pressure comes from and goes up to the top of the cylinder head, all right? So I think we're done. I'm respecting your time. The only thing that I missed in this one was the valves, the valve guide, and you guys can see it, right? So if I'm pointing to the valve guide right here, you can see it right here. So there's the valve guide right there. Then you've got your intake valve seat, and you've got your exhaust valve seat. What's the purpose of the intake valve seat? It allows the valve to sit on the seat and seal the passageway. What's the purpose of the exhaust valve seat? It allows the exhaust valve to sit on it and seal completely the passageway leading out of the combustion chamber. Okay. Now, let me throw up the chat. I don't know if anybody said anything in the chat. No. So the last person that asked was Arjun if he was late. Is there anyone that has any questions about what we covered today? So we covered the Honda head and we covered the BMW head. Anybody got any questions before I go? No questions? Okay, guys, I'm just going to go over and I'm going to shut this recording off. And maybe what I'll do is I'll put this up in my YouTube channel so that you guys can go back and make reference to it, okay? If there's no questions, guys, and you guys want to get out of here, please take your time and do the valve operation quiz. Yes. When does second semester start? In Neurum, it starts in February sometime. I'm not sure, guys. Give me 1 second. Let me run up and take a look at my schedule and I'll tell you. Let me just stop this recording.